Josh White with JW Math Tutoring. This video is going to go through the May 2022 SAT QAS, specifically Section 3, the no calculator portion of the math section. I'm going to go through those 20 questions and show you full detailed explanations of how to solve them out. Keep in mind that my explanations and solution videos are probably going to be longer than some others that you see out there because I spend the time to go through and explain multiple ways to solve some of the problems, and also briefly mention reviews of the topics covered in the problems as well as I'm going through them. So I hope you like this video. If you like the channel, please subscribe to it and sign up for notifications as well. Otherwise, let's get to it.
But life is a dream that calculus could never predict.
Starting with problem number 1 on the no calculator section of the May 2022 QAS, the US version. One thing to note is that I am using the web version of the problems, and what I mean by that is, as you can see, these are basically the problems that are posted online, and there are screenshots that are taken of them. There are, people out there who will take the web version of the QAS and then they will basically transcribe it into the same format that the SAT is offered in or given in. But a lot of times there are transcription errors, and so there are some problems that have errors on them where the answer choices are not typed out correctly, or there's something missing in the problem. It's not typed out correctly, or the formatting is off. So I'm going to use this. This is the web version. There should not be any errors in this version of the QAS, and there'll be a link in the description to it. To basically where you can find, this version, because a lot of the other versions floating around out there do have some errors, and I'll talk about the specific problems that have them when we get to them. So problem number 1, this is just basically a situation where you're given a description of a situation, and you just have to come up with a linear equation with 2 variables that describes it. So notice that the total number of credits the student is taking is going to be 16. That means, when you add up the number of credits, we need it to equal 16, so we can get rid of A, we can get rid of C. And then also notice that for the total number of credits, obviously you'd have to multiply the number of credits for the 2 different types of courses, meaning a 3 and a 4, by the number of courses being taken. So that's why it's 3 times x and then also 4 times y. So the correct answer is going to be letter B. Also, if you for some reason ran into difficulty on this problem, you could try to do picking numbers, where you could pick a number for y and pick a number for x, and then plug them in and plug them into all the equations and see which one basically makes sense. By knowing that, for example, one 4-credit course, which is 4 credits, and 4 3-credit courses, which is 12 credits total, together would add up to 16 total credits. So you just let, x equal 4 and y equal 1, and then you just go ahead and plug those in to the various answer choices and see which one works. Okay, moving on. Next problem, number 2. So they're just asking for the y-intercept of this function. If you notice that this is just the equation of a line and it's in y equals mx plus b form, i.e. it's in slope-intercept form, so it's just going to be positive 3, if you just match those things up. So the correct answer is going to be letter D. If you did not notice that for whatever reason, then you could just hopefully remember that the y-intercept of a graph will always have an x value of 0. So you're really just technically here finding f of 0. So you just plug in 0 for x and you get the same answer of 3. The next question deals with a graph. And so on this graph, basically you have a scatter plot and, so on. And they want to know what the revenue is for June 2009. So notice down here the label. I mean, it might be a little small to see on the screen, but basically the x values are the number of months after June 2009. So if we want the revenue for June 2009, that means we want the x value to equal 0 because we want exactly June 2009. We want, no months after that. We want that exact month. So then it's basically this question is just asking what is the revenue, which is the y value that corresponds to, x equals 0, or really, what's the y-intercept of this function? It is just below, this line right here, which basically would have a value of 10 because we have 0 and 20, and it's halfway in between them. So the one that's clearly closest to that, based on all these values, is just going to be A, 8.5. So this one just involves reading a graph. Next problem is number 4. Deals with a little bit of geometry, specifically similar triangles. So they tell us that ACB right here, okay, is congruent to ECD right here. So these two angles are congruent. And they also tell us that AE, the whole thing, equals 15. And they ask for the length of CE. So since we're told that these two triangles are similar, that means their sides will be proportional. Specifically, they'll be in a ratio of 1 to 2. So, for example, and that's because of the 3 on one side, to 6 on the other. So that means every side in the larger triangle ECD is going to be double, whatever the corresponding side in the smaller triangle is. So the way you could set up an equation, kind of what I'd say the traditional way to solve this would be make this x, make this 2x, and then just add them up and set them equal to the total length, which is 15. So you just get 3x equals 15, x equals 5. But notice they want CE, which is the larger side, so that is going to be just 2 times 5, or 10. So the correct answer for this one is going to be letter D. Notice an alternate way that you could solve this is basically by back solving. So you could take the answers and you could plug them in, and here's how that would work. I start with answer choice A, okay, and says, all right, CE is 4. All right, that means that AC would have to be 2, because again, in the larger triangle, the sides are twice that of the smaller triangle. Now, add them up. Do they equal 15? No. Okay, cross it out, and then try the next one. 5 and 2.5. Does that equal 15 when you add it up? No. And then try 8. So the large is 8, the small is 4. Did those add up to 15? No. So now we could get D just by process of elimination, but the way you'd actually work it out, say 10 and then 5. Do those add up to 15? Yes. So that's just an alternate way that you could solve it as well. Next, problem 5 just deals with adding two polynomials together. So all we're doing in this problem is just combining some like terms. So for example, here we have an x to the 4th, here we have an x to the 4th. So that's going to be 18x to the 4th. Now, notice we can already eliminate two answer choices, A and B, right off the bat. Next, notice that there's only one x squared term, so we're just going to copy that down, 13x squared. Notice the correct answer here is now going to be letter C. We technically don't have to do any more work to get the answer. So if this was an actual test and you were completing it, I would say at this point you select letter C and you move on to the next problem. But just for practice, for our benefit now, I am going to go through and just finish the whole problem as you were doing it, from start to finish. So next we would look at combining the x terms. Negative 5x plus 7x should be plus 2x. And then cross them out. And then last, 18 minus 9, or 18 plus negative 9. And that would be plus 9. Again, we get the answer that matches letter C. Now, Next up, we have problem number 6. So here we have an equation. Really, it's a formula that has multiple variables in it, and basically you're just rearranging this formula to solve for x. So the way it would work is, we've got y equals x plus w over z. Whenever you have fractions in an equation, a good way to get rid of them is by cross multiplying if possible. So if we do that first here, we're just going to get yz equals x plus w. And then notice we only have one more step to do. We just have to subtract w on both sides. And x is just equal to yz minus w. So for this problem, the correct answer is going to be letter A. Notice also, for whatever reason, if you're having trouble with all the letters, an alternate approach would be to just replace some letters with numbers. So like maybe it's 2x plus, I don't know, 3 and then whatever, all over z. And then if you just go ahead and cross multiply it, 2z equals x plus 3, and then minus 3, x equals 2z minus 3. And then you would just replace, obviously, your 2 with a y and your 3 with a w, just to confirm which answer is correct. That's just a little technique you'd use if all 4 different letters or variables in the problem is confusing you. Next problem is number 7, and this one is a problem where you have a linear function, or i.e. a line, and you're basically asked to kind of describe or interpret what g of 20 equals 1.376 means. So notice here 20 is the x value, so keep that in mind. And 1.376 is your input, and 1.376 is your output, or as I like to call it, the y value. So in the problem, they tell us the function gives the annual percentage increase in population, i.e. this is your output. Output is annual percentage increase population, and your input is number of years, x years after 1990. So this 20, which is our x, if we replace this, just replace this with the value. Okay, so if we read the question then, given linear function, blah, 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 20 years after 1990. So as we go through the answers, obviously A is wrong, obviously B is wrong. Okay, so we're down to C and D. And then, again, what does this function represent? Models annual percentage increase. So percentage increase, so that wording matches up so far. Doesn't say annual, but the percentage increase part matches up. And down here where it says India's total population. So notice it doesn't say anything about total population here, so D is incorrect, and it is going to be basically letter C. The 1.376 as the output of the function is basically the percentage increase, 20 years after 1990 compared to the previous year. Again, the key to this one is just, first replacing the x variable with its number, and then looking for that specific phrasing in the answer choices, and then also looking to match up the words for the output. All right, next problem, number 8. Here we have a quadratic function, and basically it's given in intercept form, and they give us also some information about it, basically that it opens upward, and that its vertex coordinates are both negative. And then it says, which of the following could be true? So a couple things to notice right away. They tell us the quadratic function opens upward. That means that a has to be greater than 0, because that's just how we define the letter a in terms of a quadratic function, whether it's vertex form or standard form or whatever. A is positive, it opens up. A is negative, it opens down. So here A is positive, it opens up. So therefore, get rid of this, get rid of that. Okay. Now, To determine between these two answer choices, the easiest way to think about this one is just to draw a picture of a hypothetical parabola or quadratic function and then see what's going on. So, okay, we know its vertex has negative coordinates for both x and y. That means it's going to be somewhere over here in quadrant 3. So let's say this is the vertex. All right, and then it's going to open up. So it's going to look something like that. So B and C are going to be our two x-intercept values. Essentially, one of them is going to be here, and the other one's going to be here. Again, how do I know that? Because this is in what's called intercept form. So now, notice here that the way that I've drawn it, the two intercepts are both negative. Okay? So it looks like the correct answer is going to be letter C. The reason it has to be letter C and that it cannot be letter D is because notice in answer choice D, they have B and C both greater than 0, i.e. both positive. Well, that's mathematically impossible because if you take the vertex, and you're drawing out a quadratic function, like, yes, you could draw the right half of it over here such that it crosses for a positive x-intercept value. But the left half of the function will always be, somewhere over here where x is negative. It's impossible to have, in other words, both of the intercepts have positive x values when the vertex is already over here, essentially in quadrant 3, or with a negative x value. So we can cross this out, and it's just going to be answer choice C. Next up, we have a system of equations, and it asks how many solutions the system of equations have. So systems of linear equations are a very common topic on the SAT, and specifically also identifying like one solution versus no solution versus infinite solution, and things like that. So first thing I would do is I would multiply this 2 times both times both terms that it's in front of in the second equation. In other words, I would distribute it. All right. So just a quick review. Here's how you can tell how many solutions the system of equations will have, and this is when both of the lines are in standard form. Ax plus by equals c. If there are different x and y multipliers or different scale factors, so they're scale factor, I'll call it scale factor, multiplier, I'll call it scale factor. If it's different for x and y, then it's exactly one solution. And the scale factor or the multiplier is, again, the number that you multiply to get from one equation to the other. So if we look from like the top to the bottom, here the scale factor is 2. 2 times 2 makes 4. However, if we look at the y's, from top to bottom, it's not 2. Okay, this number here would have to be 12 for the scale factor to be 2. Instead, it's technically 1/3. So this system of equations will have exactly one solution. Now, just to move on and just briefly review no solution versus infinite solutions, because those are the two other possibilities. There's never going to be exactly two solutions, by the way, for a system of linear equations. Just something to keep in mind. So no solution, the scale factors for x and y are the same, but it's different for the numbers. So what I mean by that is 2x plus y equals 5. 4x plus 2y equals 7. X and y both have the same scale factor here of positive 2, but the number terms on the right do not have the same scale factor. Okay? It's like, this is like 1 point whatever, 1.4. So that would be a no solution case. And then for infinite solutions, it's the same scale factor for both x and y and the numbers. So all three of them have the same multiplier or same scale factor. So if I took the last example and I just changed this 7 to a 10, now this would be an infinite solution case because the scale factor, the multiplier between the x and the y and the numbers is positive 2. Okay, so again, that's just a brief review of how to look at a system of linear equations when they're in standard form and identify how many solutions there will be. Next, for problem number 10, it's asking about the sum of the solutions to an absolute value equation. So this one, you just have to go ahead and solve it out. So identify the absolute value, or isolate, excuse me, the absolute value expression by itself by subtracting 4, and then you set up two equations and you just solve each of those equations out. So the first one looks like the original problem. You just kind of get rid of the absolute value signs. And then the second one, you can either make the left side negative or you can make the right side negative. I think it's much easier just to make the number on the right negative or opposite, and then you solve that out as well. So you just go ahead, solve each of these. First one, you should get -1. Second one, if you solve it out, you should get -5 as the answer. So what is the sum of the solutions? -1 plus -5 equals -6. Correct answer is just going to be letter A. Now moving on to the second half of problems. First up, we have problem number 11. Here you have basically a linear inequality in two variables, which is graphed out. There are multiple ways you could do this. The way that I chose to do it, or I think the easiest way to do it is to pick a test point that is in the solution, i.e. where it's shaded, and plug that in to every single problem and see which one it works in. And then if that doesn't eliminate all of them, then pick another test point or try to find some other identifying characteristic of the line. So one method to do it is I'm going to start with just 0, 0, right here the origin, because that is in the solution. So for the first answer choice, it's just going to be 0 minus 0 or 0 less than -3. That is a false statement, so I eliminate it. Second one, let's see, go ahead and plug in zeros. There's 0 greater than or equal to -3, so that one we keep for now. The third one, 0 plus 0 is 0 less than or equal to 3. That one we keep for now. And then the last one, 0 plus 0 greater than or equal to 3. That one does not work. Okay, eliminate it. So now we're down to these two choices. So we could just pick another point and plug it in and see which point works. So let's say I pick, I don't know, 0, 3. Actually, no, I don't want to use that because that's actually on the line. I meant to pick 3, 0. 0, 3 is actually the y-intercept of it. All right, so now when we plug in these points, this point to both B and C, so 3 times 3 is 9. 9 minus 0 is just 9. 9 greater than or equal to -3. Okay, that checks. Now let's plug it into the next one. 3 times 3 is 9. 9 plus 0 is 0. 9 less than or equal to 3. Does that work? No, it does not. So therefore, now we can eliminate this, and the answer is going to be letter B. So that's one method to solve this. Here is a second method that we could use, and you might find this to be a little bit quicker. So what I would do is I would first look at the line, and then I would notice that the y-intercept is 3. So the b value is 3, and then I would count to get the slope. So notice right here, I'm right on a point. I'm right on a grid mark of negative 1, 0. And I go up 1, 2, 3, and I go to the right 1. So my slope for my line is just going to be 3 over 1, or just 3. So in slope-intercept form, I've got y equals 3x plus 3. Now, if I go ahead and put that into standard form, I'm actually going to, so I'm going to do negative 3x. I'm going to subtract that over to the other side. Okay, plus y equals 3. Now, just because all of these answer choices, and just to erase them so we can see them all clearly, notice all of them have the x term positive. So I'm just going to multiply everything by negative 1. So that would flip the signs to 3x minus y equals negative 3. So at this point, I know it's not C or D. So I'm basically down to A or B. And now what I would probably do is I would pick a test point of, say, 0, 0, which I know works. And then I would plug that in, and then I would choose the correct inequality symbol to make the statement true. So in other words, 0 minus 0 blank negative 3. Or in other words, 0 whatever negative 3. And I'd say, okay, 0 is greater than or equal to negative 3, and that symbol, therefore, matches up with answer choice B. So that's an alternate way to do it, where again, I found the equation of the line first, and then I just used the test point to confirm the correct direction of the inequality symbol. Below that, we have problem number 12. Here we have another basically quadratic function, and you're given a graph of this function, and you're asked to basically determine the equation for it based on, essentially based on the values of the graph. Okay, so x represents time, and it looks like y represents height. And we want an equation between the height of the volleyball and the time since it was hit. Okay, so notice that the vertex of this quadratic function is going to be right here at an x value of 0.25 and a y value of positive 6. It's also the maximum value of the function, basically because it opens down, because a is negative. So if you think about vertex form for a quadratic function, it's basically y equals a parentheses x minus h squared plus k. And h and k are the x and y coordinates of your vertex. So this is an equation you have to know, you have to memorize. Definitely comes up on at least one, if not more questions, on the SAT math section. So all you're doing is just basically taking this form and you're replacing the x or the h value with 0.25 and the y value with positive 6. And that's it. Answer is going to be letter D. So problem number 13 is another geometry problem. You're given two trapezoids. You're told that they're similar, which again means that all the angles are congruent and the sides are proportional. And it says the length of each side of trapezoid A is 8 times the length of the corresponding side of trapezoid B. The area is how many times as large? So you could technically pick some numbers here, like say 1, 1, 2, I don't know, 3, and then, this would be 8, 8, 16, 24. And then you could try to, you could technically make right triangles to find the proportion between the height, because the formula for area of a trapezoid, it's basically the average of the bases, or 1/2 times the sum of the bases, and then times the height. And you could try to plug those numbers in and then work it out and see how much larger it comes out. But here's basically the key thing to remember. Whenever you have, like one shape which has a perimeter, or which has individual sides that are so many times larger than another shape. In other words, the scale factor in this problem is 8. between the corresponding sides. When you go to find the ratio of the areas of whatever the figures are, the ratio of the areas is going to be that scale factor squared. Because it's like you have one thing being 8 times as large, but area is two-dimensional. So that's why you have to take the 8 and multiply it by itself, i.e. square it, in order to figure out how many times as large it's going to be. So the answer to this is going to be 64. Similarly, if you were asked to find the volume of some type of 3D shape, and you knew that each side was 8 times as large, then the volumes between the two of them would basically, one would be 8 to the third as large as the other one. I think it comes out to, that should work out to 512, basically 64 times 8. So the point is, when you're finding an area or a volume, when you have two things where there's a scale factor between the lengths of the sides, the ratio of the areas is going to be equal to the square of the scale factor. Ratio of the volumes is going to be equal to the cube of the scale factor. Next is problem number 14. Here we are given a function. This is actually an exponential function, and it asks for the y-intercept of the graph. So if you remember from some of the earlier problems, for the y-intercept, that's just where the x value is equal to 0. So all we have to do here is just plug in 0 for x, and then simplify this out and get our corresponding y value. Notice if you didn't remember that, like let's say you couldn't remember like exactly that for the y-intercept, it has an x value of 0. Notice that all of the answer choices look the same. They all have a 0 for the x-coordinate. So you should look at those, and then hopefully that will jog your memory, help you remember, oh, I'm just going to plug in 0 and see what it works out to. Now you do need to know here that 6 to the 0 is just 1, and then we do exponents first, and then following that we would do our multiplication next for order of operations and get -8, and then -8 minus 4 is just -12. So the correct answer for this one is just going to be letter A, 0, -12. Next is problem number 15. This is one of the questions that there's an error on other versions of the QAS. So I've seen it both on a web version, meaning it looks like this format, and I've also seen it on the regular, like kind of typed up like SAT version. And the error in those versions is that they have just r under the square root. There is no 2 with it. And so people would work this problem out, and then they would not see an answer that matches any of the correct answers. Okay, so just be aware, this one, there is an error in other versions of the QAS. So you're given this expression to the 2/3 power, and you're asked to basically say which of these is it equal to. So what they want you to do here is basically take this 2/3 rational exponent and make that into a cube root of something squared. So the square root of 2q plus the square root of 2r quantity squared. And then you're going to take that expression that is squared, and you're just going to multiply it out using FOIL, and then simplify it. So notice right off the bat, it's obviously not A. We can get rid of that just from the start. So now if we're going to go ahead and we're going to multiply root 2q plus root 2r times itself. So notice root 2q times root 2q, it's the square root of the same expression being multiplied by itself, so they just cancel out. And the same thing's going to happen at the end as well with the root 2r and the root 2r. So at the very end, we're just going to have root 2r. And then notice for the inner and outer terms here, they're actually going to be the same because we're multiplying the same two terms together, root 2q and root 2r. And they basically each equal 4rq under a square root. Now, what you probably want to do next is just simplify each of these into 2 square root rq, because then after that, I would go ahead and combine them. We've got plus 2r here at the end. We've got plus a 2q here at the start. Now again, these two radicals can be combined because they have the exact same term under the radicals, and so we would just add the two numbers that are out in front. So we've got 2q, we've got 2 plus 2, or 4, square root rq, and then we've got 2r at the back. And again, this whole thing is underneath a cube root. So the correct answer to this problem is just going to be letter D. And again, one last thing just to review. When you have rational exponents, remember that the number on the bottom represents the type of index or the type of root. Basically, it is the index, which represents the type of root, and the number on the top represents the power of whatever is inside or under your root or your radical. Okay, the next question is number 16. We're now to the grid-in ones, and it just gives you a basic equation and then asks for the value of 2x. So the easiest way to do this is honestly just to solve it out for x and then just multiply it by 2. So you go ahead, you add 9 to both sides, you get 3x equals 15, and then you divide by 3, you get x equals 5. So 2 times x is just 2 times 5, or 10. So correct answer for this one is just 10. Below that, number 17, you're given an equation which has a radical in it, and notice they're asking for the positive solution to it. So first thing we need to do is square both sides. So when we go ahead and do that, on the left side, the squared and the square root cancel, and we just get x squared minus 9. On the right side, 4 squared is 16. And now, I mean, you technically could solve this using quadratic formula or using factoring, but I'm just going to use the square root principle because we have just an x squared term and a number term. So when we separate those on both sides of the equal sign and then square root both sides. Now technically, when you add the square root to the problem, of course, you should put a plus or minus. So square root of 25 just becomes 5. But we can ignore the minus sign because they only want the positive solution to this problem. So correct answer is just going to be positive 5. Next problem, number 18. You're given the equation for a line. Then you have another line which is perpendicular to this line. And what's the slope of this other line? So there's two ways you could do this. The first way is if you just rearrange it and just write 4x plus 2y equals 9. So now that it's in standard form, if you remember the shortcut for slope, the slope of a line in standard form, it's basically negative a over b. So it's going to be negative 4 over 2. So the slope of this line is going to be negative 2. Now, if you did not remember that, then you could just go ahead and put it in slope-intercept form. So whatever, I'm going to subtract 4x to the other side. 2y equals negative 4x plus 9, although that part doesn't matter. And then just divide everything by 2. Y equals negative 2x plus 9 halves. So now we have the equation. It's in slope-intercept form. And therefore, now we can also confirm the slope of this line is negative 2. Now we have to know, or you have to know, that perpendicular lines have opposite reciprocal slopes. So that means the negative 2 is going to turn into positive 1/2 because we want the reciprocal of it. So that means we flip it. In this case, we put it under a 1. And then we want its opposite. So I'll put a negative sign out front, and that's going to cancel with the existing negative sign. So the slope of line R is going to be just positive 1/2. Again, the reason perpendicular lines have opposite reciprocals for their slopes. So correct answer to this is 1/2. You could grid it in like that. You could also grid it in as 0.5 as well. Either would be acceptable. Next, problem number 19. Here you're given an equation, and they ask again for the value of 2x. So the first thing I would do on this one is I'm going to multiply everything by 3 on both sides to basically clear out the fractions, just because I think it's easier to work with whole numbers and not have to worry about any of that. So if you do that, we just get 2x and then 3 times -2, -6. On the right side, the 3's cancel, and we get just x, and then 3 times 1 is 3. So now we can solve this equation, subtract x on both sides, add 6 on both sides, x equals 9. Okay, so what does 2x equal? Well, 2 times 9 is just 18. And that's it. That's your answer, 18. The last question, this one on another version of the QAS had an error in the sense that the 4 pi over 5 meters here was like actually down here in the sentence, and there was no length given in meters up here. It just said has length blank meters. So you still could have probably figured it out, like the number. In other words, the number wasn't actually wrong, but just if you looked at it, it was a little confusing because it didn't quite make sense. So this is one of the other ones that was messed up in the other version of QAS. Okay, so you have a circle, and that circle has a radius of 4 meters. And then we have an arc, and let's see here, that arc, so let's say here's point A, just draw a quick picture. Here's B. Okay, this is 4, okay, we have this arc length here, 4 pi over 5. So some part of the circle has a length here of 4 pi over 5. And we want to know the fraction of the circumference of the circle. Okay, so this is another geometry question, so you do need to know the formula for circumference. So when you go ahead and just plug in, it's 2 pi r, you just go ahead and plug in the radius of 4, you should get 8 pi as the circumference of the circle. So basically it's saying 4 pi over 5 is, what fraction of the entire thing. So this is where, unfortunately, because it's a no calculator section, you do have to know how to do kind of like fraction, division or really multiplication. It's basically saying 4 pi over 5 is what part of 8 pi? Or in other words, if you wrote it sideways like this, 4 pi over 5 divided by 8 pi over 1. But now, really the way you do this is, we do state change flip, right? So we change the division to multiplication, and then we flip the second fraction. So the 8 pi goes to the bottom, the 1 goes to the top, and now we just do some canceling out. The pi's cancel, 4 goes into 8 2 times, and we get 1 over 10, 5 times 2 that was left over. So you get 1/10. So this one you could write it as 1/10, or you could write it as 0.1. Either way. But the point is, this arc from A to B represents basically 1/10 of the entire distance around the circle. That's what the question's asking for. That's how you do it. All right, so this has been the no calculator section of the May 2022 QAS, the US version. Be sure to look for my other video on the calculator section. I hope you've enjoyed this. If you have, please, like this video. Also, subscribe to my channel and also sign up for notifications as well. But otherwise, I'll see you on the next video coming up soon.